week 9 for the cis1103, and this is about very important layer, the internet layer. The internet layer in the OSI model, it was called what? It was called network layer. Okay. What do we call the PDU inside the internet layer? It is called, is it called frame? Is it called bits? Is it called segment? Is it called packet? Very good. Don't forget this. IP is the main internet layer protocol. So the main protocol used in the internet layer is IP. We have two types of IP, IP version 4 and IP version 6, used by the routers. IP version 4 is a logical network address. It's used to identifying a particular host. So you give a host an IP address. And it can be assigned to workstations, printers, iPhones, IP phones, sorry. IP phones, not iPhones, IP phones. Okay. Router interfaces that provides connection also, they are given IP address. Every packet sent across the internet has a source and destination IP address. Okay. Where we configure our IP address, I think we have done this in the lab. So you will go to your interface card and then you configure the IP address. You give an IP address, you give a subnet mask, default gateway, or your router interface. We need to learn about binary conversion. If there is a 0 in a position, do not add the value. So if I have this value here, this is equal to what? 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, which is equal to, very good, 255. Excellent. What about here? I have 1 plus 2 plus 4. Then I have plus 32. So it's equal to, very good, very good. Any questions? So this is the conversion, how it is done. You need to convert each octet or each part into its binary. We will do some examples, don't worry. Your IP address has two parts, the network ID and the host ID. Network ID, and if I have an address 192.168.0.1, what is my network address? It is the first three octets to the left. 192.168.0. This is my network address, .0. My host is 1. Okay. So if I have this sample, this is a class B, meaning that the network address is the first two octets to the left. The host address is the last two octets. So what is my network address here? .16. .16, then we'll put 00.0.0. What is my host address? 30.56. لا بس في الأول بالديفولت. Yeah. Subnet mask, it is a 32-bit value that allows the recipients to distinguish the network ID and the host address. I'll show you some examples. The subnet mask is using something called logical AND. And logical AND is only one if two sides are 1, if the two inputs are 1. Yani like multiplication. 1 times 1, 1. 1 times 0, or 0 times 1, or 0 times 0. Okay? Logical AND. Multiplication. Okay. So to identify the network address of an IP version 4 address, The IP version 4 address is logically and bit by bit. Then we find out the network address. Here is an example. Here I have IP version 4 host address 192.168.10.10. And this is my subnet 255.255.255.0. How do I know my network address? If I have 1 بينزل, you will count it. So here I have 1 نزلت. Here 1 again, 1 again, 1 again, 1 again. Here I have zeros, so it will be zeros. So what is my network address? 192.168.10.0. Now you know why we put 0, because we are doing the logical AND. We'll do some examples, Shabab, okay, in the lab. Now these are the classes. We have class A, B, C, and D and E. Class A, Shabab, look here. This is important, okay? You always get questions about this. Class A, you have only the first subnet for your network. Sorry, the first octet. The other 3 octets are for host. So what, okay. Then you have class B, 2 octets for network, 2 octets for host. Class C, 3 octets for network, 1 octet for host. Class D and class E are special. We'll talk about them later. Okay, which class will give you the highest number of hosts? Class A, very good. Which class will give you the lowest number of hosts? Class C. Very good. So here we have class A, it's from 0.0.0 /8, meaning it's a class A, yani 8 bits. I'm only using the first octet. So it's used to support extremely large networks with very high number of hosts. Okay. These are examples of class A 10.0.0. This is the network, this is the host, the one in blue, the range of hosts. And the broadcast is, you will have your network address and then you will put all ones for the other 3 octets, so it will be 255.255.25. Class B is 2 octets, 2 octets. 2 octets for the network, 2 octets for host. And this is the range for the hosts. Please remember that. And this is its broadcast, 255.2. How do we write class B /16? على طول, you see /16, this means it's a class B. Class C is /24, and it is from 192.168.100.1 to 192.168.100 to 25. This is example, yani 254. Okay. But this is the actual range from 192.0.0.0 to 223.255.255.0. If you see 195, it is which class? 195 starting, class B. You see class B 195, 191. Did I say 195? Sorry. If you see 195, it's a class B. 195 class C. Okay? Agree? So here we have our network and host. We divide our network into the big network. We divide it into subnets because this way it's easier to manage. Okay, and the hosts inside the same subnet will have similar subnet address, network address. And if you look here please, this computer and this computer, they have the same blue, which is the network address. Only the host address will be different. Yeah, like two brothers from the same family. Okay. Broadcast is when you are sending a message from one host to all the hosts except itself. Don't forget that. Unicast is from one sender to one receiver. Multicast is from one sender to a group of receivers or a group. It is very important in my network that a broadcast, now imagine I send a broadcast here in this network. It's okay, it will be only here. But will this broadcast go outside to the people in other campuses, in other companies, in the internet? Why? Because the router will block the broadcast. Block. It will not allow. It will contain it. Any broadcast will stop to keep privacy. So we call this broadcast containment. يعني يحتوي. يمنع. Okay. So here we have a broadcast containment by the router. That's why we say here, how many broadcast domain do you see here? One. Each router interface is a broadcast domain. Security. Routers is in the distribution layer can separate and protect certain groups of computers where confidential information resides. Routers can also hide the addresses of internal computers from the outside world. That's why we call it firewall and gateway. This is what protects us. Okay? The router. So here, how do we divide network? We can divide network according to the location, according to the functions, according to the, and this is like we have one network for students, one network for faculty, one network for HR. So it's easier for us to manage and provides us with security. So here we have like one network, one subnet for the floor. Okay. And we have logical grouping. Routers in the distribution layer can be used to logically group users, such as departments within a company who have common needs for access to resources. So like here, you see here we have accounting, we have engineering. But they are both in the same broadcast domain. So now, why we need routing then? Why we need routing? Because let's say here, if I want to send a packet from here to your computer, the switch knows that you are inside my LAN. So it will receive it. It will send it directly. If I want to send a packet to someone outside my router, how do I know how to send it? I will send the message to the router, and the router will check its routing table and find out which router is connected to that computer. Understood? Your MAC address will contain destination and source MAC address, and IP source and destination IP. The switch will only test the MAC address. The switch, Shabab, understand MAC address only. The router deals with the IP address. higher level. So the router will do path selection. It will find out for you the best route to send information. Okay, so let me show you here. Here we have a router. I am sending message from H1 to H4. Okay, the message will come from H1. The switch will not know anything. The switch I don't know. I don't know about this, so I will send it to the router, to the default. The router will receive the packet. It will look at the destination IP address. Oh, okay, I know where is this. This belongs to, it is connected to my other interface, to my other door. So it will send it here or here? Here. Okay. By the way, how many broadcast domains here on top? One. Why you said one? Two. Put your hands together. There is no bonus mark, no deduction.
لا it's not deduction.
Why you said one? You broke my heart. You said three. Each router interface is a broadcast.
مو بدنا الراوتر بس هو يكون اذا كان فوق كان خط واحد بس هناك يكون.
Each router interface شباب is a domain, a broadcast domain. على طول عشان هيك الراوتر is expensive. I don't buy router to connect two computers. لا no deduction.
يستاهل.
Okay. What about here, the lower one? Here. Shabab, this one. Two broadcast. Okay. So packet forwarding, I have already told you this. If it is inside the LAN, the switch will use the MAC table. If it is outside, the router will use its routing table. Sometimes the router doesn't really know exactly where is that host, but it knows that the next router knows where, so it will send it to the next router. So it's hub by hub. Okay. What about here? How many domains do we have here? Broadcast domains. Okay. The RP table shows a mapping of IP address to MAC address. Okay, if I know a device and I know its IP address, how can I find its MAC address? Using RP, okay, or ARP. Routing table entries. Yani, what do I find in my routing table? It contains network addresses and the best path to reach a network. And there are two ways routers can be added to a routing table. Either dynamically, automatically, learned from other routers, if you are using a routing protocol, or manually, you add it. A default route is the router interface used when forwarding packets to a destination that is not in the routing table. Okay, so we call this default. If a packet is distant for a network that is not in the routing table and no default route exists, the packet will be dropped. If I don't have default route and I receive the packet, I will drop it because I don't have a default route. Otherwise, if I have a default route, any packet that I don't know where it's going, I will just send it to the default. This is the default gateway. Here, the same concept. When a host sends a message to a device on the same network, it forwards the message directly and uses ARP to discover the MAC address. When a host sends a message to a device on a remote network, the host uses the MAC address of the router as the destination, but still have the IP address of the remote host as the layer 3 destination. Okay. Let's finish these 2 slides more. Static is something you add by yourself, the IP address. Okay. You can assign static IP address to the host. We have done this in the lab. We will do it again in more labs to come. We can also use dynamic assignment using what? DHCP. Using DHCP. And we will do one DHCP lab. And the DHCP will have a scope. The scope is a pool of addresses available to be leased to users or to hosts for a limited time. Yani we call this duration, for defined time. What are the benefits of using DHCP? Reduce the burden on network support. You don't have to go to each computer and assign IP address every time they turn on their computer. Dynamic IP address is not permanently assigned to a host, but it's only leased for a period of time. So you have control. Okay, it's more efficient. It will not do duplication, because if you assign two hosts the same IP address, they will not work. Okay, thank you very much. Do you have any questions?